Good afternoon, everybody. Once again, thank you for attending the RTI Advanced Control University Tech Talks. Today's Tech Talk is concerning the RTI two-way strings driver. It's been a driver that we've had for quite some time. And with me today is Mr. Paul Kia from our integration team. Hello, Paul.
Good afternoon.
And today we're going to talk a lot about what this driver is, how it works, and in all honesty, we get a lot of questions that people just aren't sure what it's supposed to do, what the premise of this driver is, and so we really want to deep dive and give you an information, basic to advanced, on how we could use this driver and the parameters based around it. A couple of quick notes for you here. You'll see my email in the upper at the top of the screen. Please make sure to let us know and let me know if you have any additional questions after the webinar here today. As always, please do post your questions in the question area, and we'll get those answered as quickly as possible. Any questions not on topic, we will address, of course, but not until after the end of the webinar. Also, we invite you to become part of the Integration Zone Forum. This is a great opportunity for you to let us know your ideas as well as provide feedback and communicate with RTI directly. Our Paul's on there, I'm on there. Our sales marketing team are all on there. Our engineering teams are all on there. We want to know what's going on in the field. So please let us know. And then if you need drivers in the field for products that you're working on or devices that you're working on, that's the best way to be able to post those. So we'll talk a little bit more about how drivers are created here in just a second and kind of the process. But just to give you an idea, those are going to be two great resources for you, my email as well as the Integration Zone forms. So please make sure to either write those down or, as always, I am recording this video and we'll post it under the pre-recorded training video section for you to view at a later time. So let us know if we can help you in any additional way. Don't be shy. We want to see those questions. We want to get them answered for you here today. That's why we host these Tech Talks. So the agenda for the talk today is going to go through a basic overview of the driver. I'm going to walk through it step by step, give you what you need to make a good quality experience for your client utilizing this driver. We'll talk about some of the specifics around it. What some of the terminology is based around the driver, and then really kind of give you a demonstration on how it works and how it's supposed to work and what you can expect from it. So, like I said, if you have any questions, let us know. Now, regarding the development of a driver itself, there's really three key parameters when it comes to development of a driver, and one of those is making sure that we know what you need in the field, and letting us know, through the forum is the best way to. No, we don't do drivers on demand. I wish sometimes our clients wish we did, but we don't do that. But what we do ask you to do is post it on the forum under the driver request section, because the more times and the more people that request that driver, the higher up the queue it gets. The more times the more people that request the control over a certain device, the higher up the queue it goes. So let us know what you need, and that's the best way to do it. In addition, we not only need demand in the field, but we also need some product in-house. If we're trying to write a control driver for a device that we don't even have, it's going to make it very difficult for us to test to make sure it actually works. So actually having the product in-house is a vital part of the process. And then, of course, third, we want to make sure we have support from the manufacturer. Now, having that support of the manufacturer, it doesn't mean that we are hand-holding with them every step of the way. It basically means that we're going to have a go-to person when we run into bugs or questions and issues that might come up through testing and us writing this driver. So we want to make sure that having those three categories, having those three parameters makes us a successful driver. I'm not saying that any one of those missing is going to kill a driver, but it does severely hamper the release time frame on it. So if we don't have the product in-house, we're not going to release it until it's tested. We're not going to just, as good as Paul and Troy and Jason are at this, they know full well that they want to make sure it's tested first before releasing it, and just not say, oh, it's done, good to go. Well, maybe Paul. No, I'm just kidding.
Ought to work.
So we go through that process, make sure, if there's no demand for something, we're generally not going to write it unless, these guys want to do it in their spare time. Now, in terms of actually getting the driver and pulling it up and downloading it, we'll talk about where that's located in just a few minutes here. But when we start talking about this specific driver and getting started with it, a couple of things that you need to be well aware of. First of all, always make sure you have the latest firmware and software updated on every device. If you're an integration designer, it is a vital part of the creation of a control system. You want to make sure you have the latest firmware and software. If you don't have the latest firmware on the processor, does it mean that driver won't work? Well, sometimes it does actually, because if we add in a specific um, category or a new update to that specific driver that maybe we've developed 5 years ago, and we've just done an update to it, well, that's going to make it very difficult for that processor to run if it's not up to what we've developed it on. So make sure you have the latest firmware and software for all the equipment and your integration designer. Also, when you download the driver from the driver store, you're going to get two files within that sample within the zip file here. And I'm just going to pull up integrate pardon me, the driver store real briefly here, just to give you an idea. So under the RTI dealer site, you'll notice that there's a listing here, and you can scroll through the list if you so desire, or you can type in a search or do a category of what you're looking to do and all that kind of fun stuff. So if we typed in 2, I believe it should just populate down here. Maybe. Come on in. Okay, so there's our RTI two-way strings driver. And we're also going to give you the version number, and then we've also started giving you release or update dates on those as well. So you'll see those populating. When you download this, you're going to get two files. Like I said, you're going to get a zip file, and within that zip file, two files. You're going to get the RTI sample file, and you're going to get the RTI driver file, .rti driver. The other thing that you're going to need to do for this specific driver is make sure you get the protocol documentation of the device you're trying to control. This is vital. It's not going to work unless you have this. So make sure you get the protocol documentation. Now we're not going to have a listing of that on our site. So you're going to need to go to the manufacturer and pull that from theirs. And I'll show you one here in just a second. But really, this is, these are the three keys to making this driver work. Obviously, you need the driver, but taking a look at that sample file, things of that nature, and then making sure you get that protocol documentation for the manufacturer is vitally important. Always read the get info. Do you say that's pretty important, Paul?
Yeah, that's absolutely number one. I can't tell you how many times we'll answer a question that could have been, someone might be in a queue in tech support or wait a while on the forum for response, and the response is, well, as it says in the get info. So yeah, particularly if you get hung up on something, that's the first place to look.
Would you do it even if you're doing an update?
Yeah.
Or if there's an update for that driver that you've used before?
If you've used it before and the driver gets updated, and that goes actually back to what Tyler was saying earlier about making sure firmware is updated. A great example is actually the email driver from yesterday that we had solved a problem in there with some of the more advanced SSL compression stuff. So at one point it was pretty limited in the number of servers you could use, but with the latest release we solved that, so it does just almost all of them. And so that's when you see the new version, you have to look at the get info to see what that difference is.
Absolutely. And then on top of that, you want to take a look at that sample file, right? I mean, that sample file is really going to show you where those commands go in a variety of different fashions and examples for you. Even a simple driver like we talked about yesterday with the email SMTP client driver, I mean, that was pretty simple, but even the sample file, going through it, we wanted to make sure that, pardon me, that you saw the different types of commands that were available and where those went. So make sure to take a look at that sample file. It'll answer a lot of your questions, help you. Basically, the sample file is a good way for you to work backwards on the driver to figure out where things go and how they work. And a lot of times you'll see those devices on there that will be in virtual panels. So you just be able to load the sample file onto your processor and then load it and then have that virtual panel on your computer right in front of you and look at it and see how it works. So we'll pull that up today as well and kind of give you an idea. So when you're getting started, these are the major things about the driver. Now let's get into what that driver is. So let's talk about what the two-way strings driver is. And really, it's doing something really, really unique and gives you the opportunity to actually connect and get feedback to and from a device with no driver available. For example, if you're trying to work on a specific projector and there's not a driver available, but you can get a serial or a network connection to it, you could get and send you can send command and get feedback like power status and things of that nature on it, even though there's not a driver available for it. It'll allow you to send commands via the network on a singular button if you wanted to. You can issue a you can issue repeat commands consistently to keep a device awake or on. And keep in mind, you will always need that protocol documentation from the manufacturer because it's going to give those in-depth details about what those commands are and how to set them up within that driver itself. Is there anything you want to?
No, I was just going to say that obviously the documentation is important. With this driver, you're doing a lot of the same things we do when we write a driver. But obviously, as far as the device you're controlling, that's not part of the driver. We're actually giving you the mechanism for sending those commands. And if we had had the protocol documentation or we had that box, there might be a driver. So now you're actually taking that part on and deciding, figuring out what commands need to be sent. In ID already, you can do that with serial strings, but now this is a kind of a bigger way of doing that. But once again, you're going to have to find out from the manufacturer what those actual commands are.
Should we show them an example of it?
Let's show them an example of that.
All right, so I'm going to just pull up here real quick an example of a protocol documentation in regards to a dead-on audio-video receiver here, the AVR X4000. And you can kind of see as we go to page 2 here real quick that here are the specific connector specifications. We haven't gotten into those, the connector specifications yet, but you can see the detail that's involved on here. You're going to need to reference this information. You're not going to need to know it as you're working with this driver because it's vitally important for it to know how to send things, whether it's RS-232, Ethernet, and knowing which port to use, and even further down, and we'll reference this here in just a second, but the actual commands and the parameter listings of what's available on this specific device.
Yeah, obviously, there's no standardized format that you'll find this in, and this is, almost half the detective work of what you're going to have to do. This is a pretty good document because, over on the right, it actually gives you an example of exactly what you need to send. You'll find some of people do this in this type of PDF file. Some manufacturers have it in an Excel spreadsheet. Some of them do it in kind of a weird on your PC web document, but this is where the information is, not just to send, which a lot of you may have done, but with what comes back. So.
Right. So let's start with the first level of this two-way string driver, which is called one-way strings. And really it comes down to the connection type. And this is going to be important for the two-way side of it as well, but the one-way strings, we can start talking about them. So if you want to start going into these a little bit, Paul, and tell us.
Yeah, I mean, serial, we've already done. I think most of you know that if you just need to send a serial string to a device to control it, we've got serial libraries, RS-232 libraries. We have the ability to put those strings, on any button. That's not new. But if you end up wanting to, repeat them, then maybe you might want to use this driver. Where this driver, as far as one-way goes, really becomes necessary is, it's fine to do that on the button with a serial string, but if it's a network connected device, if you're going to do it with TCP, then you have to use this driver. There's no other way to do it. So a TCP connection is a network connection that when the driver starts, there's actually a connection that's created between the two of them. The processor itself keeps the TCP connection open, so there's always two ways going back and forth between devices. UDP is a little bit different. Technically, UDP is it's often referred to as connectionless. There isn't a connection in the classic sort of way we think of on the network. It pretty much uh, opens the port. It doesn't really know whether the device even heard it. Um, we have a little bit of a unique system in the way we do it, in the way we do UDP, which is probably technically uh, not exactly standard, but typically a UDP packet that goes out, um, the PC will just pick a port to send it on, and the UDP information is the address and the port that it goes to. When we open that port, we actually make sure that our command comes out of that port. So a system on the other end will know what port it came from and can actually respond. But most of them don't really do that. You can do that to make the one. Uh, you can use one version of this on two separate processors and have them talk to each other, that sort of thing. But generally, UDP is typically going to be mostly one way. Usually, if you're going to actually, when we get into the two-way part of it, it's going to be TCP. But UDP is just another way of sending network packets. But typically, you're going to find a UDP connection to be one way.
All right. How about in terms of sending hex characters and escaping?
That's one of the ways that this driver differs from what you'll see actually in ID. I think if you've done it with serial strings in ID, you know the /R or the /X for doing the hex characters. The heart of this driver is actually in JavaScript, so it escapes these characters slightly differently. Instead of using that slash, you use the %sign, and then the actual 2-digit hex value of the character you're trying to send. So if you're sending the character return, that's the %sign 0D, and that sort of thing. So if it's not a printable character, you'll find sometimes in the protocol, the start of transmission and end of transmission are two that you see a lot in hex-based stuff that are actually hex characters 2 and 3 actually. So if that's in your protocol, and once again you'll find that from the protocol document, you'll see you'll start it with a %sign 02 because you're always using 2 digits. You'll end it with a %sign 03. Those characters are actually used, the RTI doc does that. But any character that's not printable, that you can't type on the keypad, you'll have to escape, use its ASCII value, and you do that instead of the slash like you use actually on an ID button to send a serial string, or in the serial library, they'll use the % key for that, %sign.
And the CR you're referencing is character return.
Character return.
Yep. Okay. Great. And then the other one is this ping for repeating commands. So we talked about being able to repeat the commands that keep a device on. That's where the ping comes in, right?
Yes. Yeah, ping is it comes from, it's obviously a fairly common networking command you see on a computer when you're trying to find out whether you can reach a device on the network. You send the ping. Ping is actually a defined command. In the driver, the ping is not an actual ping command. It's a separate string that you put into the configuration of the driver, and then you tell the driver at what rate you want it to send that command. So you can build a string, say I want it to repeat every 10 seconds. In the driver, it's actually in milliseconds. So if you wanted to do every 10 seconds, you'd say 10,000 would actually be the number. It would be 10,000 milliseconds. But that actually, in one-way strings, that's exactly what it would be. Keeping it awake, it would make sure that if you had something you wanted to make sure was always in play, you would send that command every amount of time to make sure that if someone stopped it, it started up again. So you have the ability to set a string that can repeat as often as you want.
Perfect. The next level goes into the two-way strings. And that's really where we're receiving the information back from the device and using variables to display it to the client, right? Again, it goes back to being able to show them, say, power stats or volume levels and things of that nature where normally they wouldn't be able to, but the simple fact there's not a driver available to. But this two-way strings would give you that option. So there's something called framing within this two-way strings. Can you elaborate a little bit more about what framing is?
Yeah, framing actually applies to one-way strings as well, but it's most important for the return information. In the driver, if every character, when you're sending a string, if the protocol documentation says, for instance, that every command has to end with a carriage return, you'll put that in the string as you send it. But on data that comes back, the processor doesn't know anything about that data that's coming back. It's the driver that's going to do that. So something has to tell the driver or the processor how to group this data and get it and present it as a bunch of bytes to the driver. And usually that's done with framing. So what you'll find is that the data will come in, and most protocols will have this. And matter of fact, fairly often it's a carriage return. I think in that Denon one we saw it was a carriage return as well. Every command ended in a carriage return. Yeah, if you look at the examples, they all end in carriage return. So if that's what you do is in that case you set your carriage return as essentially the stop byte for the string, and then when a carriage return comes in, the processor will know, okay, now I've collected enough. That's a whole command, and now it'll send that as a bundle to the driver. Yeah, should. Yeah, I don't know. Anyway, so if you don't do that, there's a possibility that the driver will work anyway. Usually they come in a packet, particularly TCP commands come, they get sent in one big packet or one packet. The problem is if the return does get too large, it's possible that it'll get sent in two, in which case this packet of bytes that you're trying to parse, that you're trying to figure out, might get broken in half, and the data won't be where you expect it to be. So that's exactly what the stop byte does. The processor holds onto the data until that stop byte comes in, and then it actually takes all the data it's gotten up to that point and passes it one time. That way you know you've got a complete string, and the processor, the driver can go through it and you can be confident that you don't have half a command, that the data is actually in there. So that's what the stop byte is for. The start byte is just a little additional help and maybe rejection of some bad data. It can happen if there's bad data or if there are multiple types of commands. If you have a start byte, the processor actually doesn't collect any data, doesn't collect any bytes until it gets the start byte, and then it collects all the bytes after that until it gets the stop byte, and then passes that. So once again, if you've got maybe some noise on the line, if you've got a real long serial cable or something happens, some extra bytes get in there, they'll just be ignored until the start byte comes. Or some devices may have 3 or 4 different types of status. Status for the status for that tells you power may be different than the status for metadata, and you don't want that flood of data from the wrong type of commands coming in. If you can sort it out by start byte, it actually lets you cut down on the number of times that data gets sent to the driver. So the stop byte is very important. The start byte is a big help. It's a little extra insurance. You can't have a start byte without a stop byte. But like I said, the stop byte is the one that's the big deal.
Cool. Should we show them what we're talking about?
Yeah.
All right, let's bring this up here. I'm going to open up ID here for us real quick, and this is essentially the sample file that you will get from us. Again, we would need to load that driver into the driver section of the processor, as you can see here. Always make sure to read the get info. Again, here's where you'd be able to get all the information regarding that specific driver, how to set it up, different revision histories, examples, etc. And then, as always, in the library browser where the commands and variables are, you can always access the get info from this button in the far right-hand corner as well. So I'm going to expand this out a little bit so you can see what we're talking about here. So in terms of once we've loaded this driver in, read the get info, it's basically as any other driver is, except we need to go through and do a little bit more setup on this because of what's involved, right? So in terms of the connection type, here's where you choose your connection type: UDP, serial, etc. So if I were to select serial, I'd go ahead and enter in the serial port, baud rate, data bit, stop bit, etc.
Once again, that's all information that was in that protocol document. Uh, it absolutely won't work unless that information is correct.
Right. So this is information from the device that you're getting the protocol document from, right?
Right.
Not like the RTI device. Now, if it's TCP or UDP, you're going to have to enter in the network information up top here. So the network address, network port, all basic information. But then here is that ping string, that ping time that Paul was referencing earlier. So
yeah, that's a great example right there. That we're doing this for the Yamaha receiver. The Yamaha receiver has a command that actually tells it that actually asks for all the what they call their basic information: the power, the volume, the input of the receiver. And one command tells it to return all that information. So we've got this set to ask for that information every 10 seconds. The Yamaha does happen to, if any of that information changes, it does actually send that information when it changes. But this way, if you started up the driver, even if it was listening, you wouldn't have until the volume changed. You wouldn't get a command that told you that. So at some point, you've got to ask it, at least at the beginning, for that information. Some devices you will find there are devices that don't give you that information. When we're writing drivers, we refer to that as unsolicited status. It's great to get that. It's great if a device, when there's something that changes, tells you right then. But a lot of devices, particularly a lot of web-based network devices, don't do that. You have to ask them for it. And that's what the ping can do. You can put a status request in as your ping string. You see right beneath it, it says 10,000 for the ping time. That's 10,000 milliseconds. So every 10 seconds, it sends out that string.
Perfect. Minimize the serial port. Here's that framing that we were talking about again.
And once again, even with the escape on the stop character, that's the character that at the end of every string that you're going to get from the Yamaha receiver, you're going to get that. So that's how the driver, that's actually how you can be confident that you've got the entire string. Without that, if it gets broken up in the middle, or you're missing some bytes at the beginning, the matching of the strings might not work correctly, and the driver wouldn't work. So that's what the stop bytes are for. In this case, they also do all their commands start with that with the @ symbol. So that actually tells anything. The driver will, the processor will completely ignore anything until it gets that @ symbol, and then we'll collect all the data till a carriage return happens, and then it will bundle that data up and send it to the driver as one. And that's very important because it's got to look in the whole thing to match up these strings, particularly to try to parse and extract the data from it.
So this framing basically then is taking the taking that string down, as we can see, string 1, and then ending it and putting this on every single time. So we don't need to put the entire thing on every single one of these.
Actually, what ends up happening is in the reserve string itself, what you'll see is where we have RX string 1, the actual command that comes back from the receiver, like I said, it starts with that @ symbol. And in fact, in this case, it would be @main : INP equals. And when the input for that receiver is on Sirius XM, the end is actually Sirius XM. So, but what we've got to do is tell the receiver or this driver is going to look for what we put in here as this parameter inside the driver and see if it's going to look for it inside the string that got returned, and it's going to look for a match. So we don't really need the @ symbol. It's going to, you only need as much data in there to be unique, but you probably also need enough so that when you come and look back at it later, you remember exactly what the heck you were doing. So if you just put SIR in there, it would probably still find a match, and it would still trigger the event when main input equals serious came by, but you might not remember later what that actual command was, and if you had to add another one, you'd have to look up a lot more stuff. So it doesn't, if you had the @ at the beginning of the main, it would still work. You just don't need it. Gotcha. But the whole point here is when that string comes in, and that string will have the @ at the beginning, it'll have the carriage return at the end, but in the middle of it will be, if the driver finds in that string that main : input equal SIR, it will decide that that's a match, and it will trigger an event based on, it will, essentially string one, the string one event, which you can use to do whatever you want, set a flag. Perfect. These first, whatever, 8, 13. Well, the first 8 are actually distinct particular inputs on that Yamaha receiver. So when they come back, you can use them to set whatever, a specific flag. So if you want to have, if you want to reverse a button, you can set a flag for each one of these. And I think, we'll actually get to show that a little bit later, because we're going to actually do a pretty good emulation of a Yamaha driver later on. So we need to have discrete variables for each input. But you'll notice that when we get to string 9, the string is actually a lot shorter. And what happens there is any one of those commands, once again, it looks for, when it gets a string in, it takes that RX string 9 and looks in the return for that. So even though it saw it in number 1, it continues on down, and when it gets down to string number 9, that's a second match. So now, if it changes to tuner, essentially that will trigger the event for RX string 2, but it will also trigger the event for RX string 9. So RX string 3 will happen anytime you switch to USB. RX string 9 will happen anytime any change happens to the input at all. And once again, this main : input, it seems archaic, or not archaic, arbitrary, but that is exactly, if you look in the Yamaha documentation, that is exactly what it returns. If you were to look at it in, a terminal program, what was coming out of the receiver, you would actually, this is exactly what you'd see. Well, actually, you'd see the @ symbol at the beginning, but you would see those actual characters and see that those strings all match up. 10 does, once again, volume. Any volume command would match that. And then 11, 12, and 13 do actual specific metadata for the streaming services. In addition to doing these, there's an event for each one of these strings. In addition to that, if there's a match, if we want to go down to what the driver tries to do is it's going to now, no, that was right, but we have to scroll down a little bit. Remember I said that string 9 would get triggered anytime there was any change in input. Anytime that longer string, that main : input equals happens, string 9, the event for string 9 would be triggered. But in addition, when that happens, it actually goes down and looks at this next section where there's a prefix and a suffix. And what happens is it goes through that string. Now it's identified that there was a match. 9 was a match. So it goes down and looks for this string, this INP equals. And once it finds that, it drops off that and anything in front of it and then goes through the string farther and it finds the suffix. Now we don't have a suffix in here, but if it found a suffix, it would cut that off the back end. And what's left, it actually writes to a string variable. If you look over in the variable section, there's an RX string variable number 9. So knowing what we do from the front, that it was the main input equals Sirius or tuner, if we take anything, if we only use what's after the INP equals, it will actually leave us with a string that actually says tuner or AV1. The actual name of the input is there. So that actually gives us, now not only do we have an event that we can use to set a flag for every specific input, we now have a text variable in RX string variable 9 that actually tells us exactly what the input is. So we can show it as text, or we can reverse a button based on that. The other thing, actually, you can see, if we just skip down just a little bit to 11, right there, 11 and 12, you'll see that anything that came after that album equals or artist equals, so that actually any of the streaming metadata that comes in actually triggers that too. So now we also have all the artist metadata, album metadata, track name, artist name, album name, that we're actually able to display once again without a driver. The interesting thing about the Yamaha is that once again, that's a much larger command. Instead of being at main colon, it just so happens that for the receiver, that main gets replaced by whatever the source is. So if it's Pandora, or if it's actually has Spotify, it has whatever it has for the service, that's after the at. But we actually are not looking for that. We're just looking for artist, and then we'll use what's after that. So if it doesn't matter what's before that. So what actually ends up happening, regardless of the service, the artist will always be the same. So string 12, RX string variable 12 will always be the artist, whether you're on Sirius XM or whether you're on Spotify or whether you're on Pandora. So there's one final step in this. If you look at string 10, like I said before, actually I guess there's going to end up being 2 steps. But as I said before, now any volume command, the fact that there's an event when volume changes is really not useful necessarily. But as I said before, now you can go up here and anything after that volume equals becomes string variable number 10. So you actually can have you can actually display the volume of the device. So you can have a text button that actually has the volume in it. The one problem with this is, once again, this is a string, so you can put it on a button, you can see it, but you can't use it to drive a gauge. You can't. And matter of fact, you can't use it on a gauge, I guess, is the main thing. There's, as far as volume goes, there are other things you might do with other ones, but as far as in volume goes, we're talking about a gauge. So the next step in this, if there's a prefix and a suffix and it ends up with text, a section of text, the next thing it's going to try to do, if we go down a little bit farther, is it's going to try to take that information. It's going to take that information and it's going to try to make an integer variable out of it. Actually, probably the best thing to do is go over to the variables, and you'll see after the 50 string variables, there's integer variables. So we have string variable that does the volumes in number 10. Tyler's going to die on me here.
Sorry.
So we've got, if the volume level was 50, that would be a string, but you can't use that on a gauge. So it actually then tries to make an integer out of it, and that would show up as that integer variable. Obviously, if it's metadata or something like that, then that string is not going to work. That variable won't be anything. But if it works as an integer, then it'll show up there. So now you've got, from any return, we have the driver going through and finding strings and integers. So here's one last problem in that. The problem with with the receivers is, and some other devices, is they're not necessarily always integers. You've probably seen on the receiver, and the Yamaha is definitely one of them, that the volume level can be 13.5. You go up one notch, it goes up to 14, then to 14.5. So you've actually got you don't have integers. You actually have a floating point number. ID can't do floating point, um, and drivers don't know how to do that. They can't. The driver can, but the variable system doesn't. So variables can't be floating point. So what we do is to preserve that precision. We can actually tell this driver to essentially multiply it by 10, and that's what that information is right there. So now what we've got is instead of our 13, 13.5, and 14, we've got 130, 135, 140, 145. Those are what the variables are. The important thing to remember is if you have to do that, that your gauge numbers are going to change. Instead of having a range on the gauge from say 0 to 50, you're going to have 0 to 500 if that's what you do. We'll show when we get to the sample. Obviously, you don't want to show that number at 160. Instead of 16, your choices are, once again, your string variable will always say 16. It doesn't get multiplied. But there is a way, and we'll show that when we get to the sample file, how to have ID show that already shifted back down to give you your 0 and your 0.5 back again. So that's basically how you get those variables out of there. Once there's a match on a string, the driver will go and look at the suffix and the prefix for that string and strip everything away from the data. So if you have data that you want to write in the middle of that string, you just put the characters that are ahead of it and the characters that are after it. They kind of frame that data, put them in as the prefix and suffix. The driver will just take that data in the middle and create that string variable, and then it will try to make an integer variable out of it if it's actually a number. So that's the whole idea right there. There's only 3 or 4 steps, but it can take an effort. Once again, it's not always as plain as all that. The Yamaha's a great example because it's all it's all basically text that you can read easily. Once again, if you start doing hex characters, you'll have to escape stuff, but the idea is still the same.
A question just came up. Can I ask you how you'd put in a carriage return in the stop bits as per your Denon protocol?
That's it right there. Actually, you have to escape it.
Which is the percent sign.
Actually, 0. Now
Should I pull it up?
I'm sure someone will correct me, but I'm forgetting now whether 0A I think is actually the line feed, and 0D is the carriage return. Either way, whichever one you end with, that's what you have to do. You have to put the escaped version of it in there. So that's how you do it right there.
So you just change it here,
Yes.
and then it would affect all the strings down below.
It affects strings you return. It doesn't add the stop bit to the end of stuff you send. If it's in the stuff that goes out, you have to put that every string yourself. But with stuff that's coming in, it will automatically do that. On stuff that's coming in, it has to know how to break up this string. So yeah, that's exactly it right there.
Perfect. Should we show them an example of what we're talking about here?
Yeah.
So here's the virtual panel for the sample file. I'll pull it right here, maybe. No. Let's see.
Yeah, and actually, before we go looking at the stuff we've already done in specific strings, and there are several variables in there that are designed to help you figure this out. You have a variable that shows you're connected. If you have a TCP connection, you're going to a specific IP address at a specific port. Once again, those come from the documentation. But once the processor itself is going to have to make that connection. Until that connection is made, nothing's going to happen. So you have a variable that tells you whether you're connected or not. That's right there in the center of the box in the sample file, um, where it tells you whether it's connected. Um, you also have, yeah, it just tells you true or false. Once you're connected, that'll change to true. So, this stuff we're looking at in this box is pretty much troubleshooting stuff. But, like I said, it'll take you a few tries to get this right. The receive string and the transmit strings, you have two things. You have a count. Just every time a string comes in, that count goes up. Sometimes this stuff may all happen, faster than you can see it go by, but you'll see the count goes by, so you'll know if it's actually receiving strings. You'll see the count. It'll show you the last thing that got received, and so that's always a good thing to look at. If you're having trouble receiving something, you'll see in the receive string exactly what came in. You may find out that you may have a typo in your string, or there may be like that colon that's in there. If you forgot that, or maybe there's a space in there what actually comes back and you didn't see that in the protocol. So that actually shows you what's actually coming in. Like I said, sometimes they come in really fast, so you'll just see the count go by, but you should be able to see the last one. And the same thing with the transmit string. You'll see what the last thing to go out and how many things that have been sent out. So those are tools you're going to put in there. Obviously, in the end, those aren't going to be in your page. Those aren't really part of the connection or what you're trying to do status-wise. But as far as getting your strings to work and getting stuff right, those are going to be invaluable.
All right. So we kind of go through this example then of what we've got on here?
Yeah. This is actually, the Yamaha receiver. Now, we've already got a driver for that, so this is probably not one that you would do, but the whole idea is the same. If you look at the power button in the upper right there, and you get the properties for that button, there's only one command in this driver, besides resetting the counter, but you'll see that there's a string that you're sending out, and you can see exactly what gets sent out. There's that looks familiar because we've already done it. That's the string that actually goes out.
What's this comment?
The comment is, a lot of times you get into escape strings, and sometimes hex strings are all you get. At which point, if you looked at that, I had to go back, 3 years later to this job, and you're trying to figure out what that string was for, you'd have no idea. The comment doesn't do anything in the driver, but if you hover over the orange dot next to the command, you see actually that string, but if that string doesn't mean anything, you can type a comment in as that comment parameter, and its only job is to show up right there. Like I said, hovering over it, but it's obviously, right there as well if you just right click. But yeah, you can see he just said that's the power toggle. And that's, once again, it's just to help you remember later on what exactly the deal is.
So it's like we have in all the macros.
Yes.
That we can do.
Yeah. So if you look at any of those commands on any of those buttons, you'll see a very similar string, but that gets back to the strings we were talking about before, that main : input equals. But once again, in this case, you've got to have the actual command from the @ all the way to the carriage return, actually the carriage return line feed that in these commands, and the full name of the input. Once again, that information comes from the protocol document, but you're just putting whatever string you need to on each particular button. So you're not defining strings to send. The string is a parameter for every command. So you have 50 receive strings, but you have essentially an unlimited number of send strings because you do it for each button, just like you would if you were using a serial command, an RS-232 command on a button.
So are they going to need to type this every time, or can they just drag the send string from the driver commands over to a specific button?
Well, the first time you do it, there, yes, you can put it in the parameter.
Did this to us yesterday.
I don't know why it's not showing up there. But like any other variable, it'll show up in the, there you go. That's where you type the string, that's where you type the comment, and you can drag that onto the button. What you're probably going to end up wanting, like in this case where you're doing the at main colon input equals whatever, you're going to want to make one button. You'll drag it on the Sirius XM. You'll duplicate that button because it'll already have the command on it. Then you can open up that button and go in and highlight Sirius XM and type in tuner so that you're not typing the whole command every time. So a judicious use of cutting, copy and paste there. But basically, when you're sending something out, you're creating the command every time.
So it might be a good idea for them to create a sample or a base template for the two-way string driver for a device that they might be using if they think they're going to use it again. So they don't have to go through this every single time. They can just copy and paste over or import that over.
Yeah, without a doubt.
Save them a little time.
Save you a little time. Yeah. Yeah, in particular, it's one of the things when you can save a configuration of a driver, so that would save all of your receive strings and all your prefixes and your suffixes and your multipliers, your framing, all that data, but it won't save your buttons because they're not in the configuration. So yeah, whether you want to import the page to get those commands or whatever you want to do, if it ends up being a receiver that you use multiple times or some other device that you use all the time, a projector that you're switching the inputs on and doing power, you're going to want to create a page probably that has all the buttons on it, even if they're just crammed all onto one page, just so that you can copy and paste them to where you really want them to go. So then we had talked before about the input strings that come back, and in particular, if we go back to escape to receive strings, we're going to have to follow the logic here now. If you look at right what he's pointing at, the input equals tuner, right? So say we get that string back. That's going to create a driver event. It's going to create driver string number 2. So if you look under events on your tab here, you'll see that we've already created them. So that driver event, the RxString2 driver event, is going to trigger a macro. Now, we've called that macro tuner. And so if we go to macros and go to the tuner macro, we'll see we've created a set of flags that correspond to the inputs on the receivers that we care about. So when the tuner gets selected, we set the tuner flag, we clear the other flags, and you'll find any of the other inputs do exactly the same thing. We get the string 1 in, which is the Sirius string. We'll see that actually sets the Sirius flag and clears the rest of them. Now, if you go back to the sample page and look at the LED properties, you'll see that we use the flags that we created.
Tuner.
Well, either way, yeah. The flags that we created are the flags that reverse those LEDs. So the logic trail, I guess, is that string comes in, it matches up with a particular string in the configuration, creates that event that triggers a macro. We use the macro to do these flags, and then use the flags to reverse the buttons. So now what we've done is we've created these 8 buttons. Now we've got, not only do we have these 8 buttons that can switch our inputs, these 8 buttons, those buttons will reverse, or at least the LEDs on them will reverse when we switch to that one. So now if someone switches it from the IR remote or switches it from the front panel, we still get the reversed LED. It still lights up. And so that's really the essence of two-way right there. Is even when we didn't do it, we didn't control it, or got turned off and came back on, or whatever, it is actually following the the actual status of the system. So um,
How about in terms of the volume
the
level?
volume, yeah, the volume once again works kind of the same way. Actually, in this one at the well, I guess I should almost farther up above those set of buttons there. There's two variables, and I had said before that we have string 9 that actually the first 8 strings actually do the events that run the that that reverse those flags. But like I said, in addition, it actually goes to the prefix and suffix and looks at that and creates a text variable. So that's return had came in. We threw away the head and the tail of that, and as I said before, we were left with just the name of that input, and that's what that variable is right there. So that's the text variable for number 9. So once again, the first 8 are triggered by a specific input. That 9th one is triggered actually by any input change, and so strips the outside off and gives you a text value that shows you what the input is on. And the same thing happens above it. If you remember, text string 10 was volume equals. So once anything with volume in it comes in, it strips off that and leaves you with just the number. Once again, it's a string variable, so if it's 16 and a half, it'll say 16 and a half. And so you have a variable that just shows you the volume. The problem is that you can't, once again, you want a volume, you want a gauge for that. If you look on the gauge itself, oops. Yeah, once again, it does gauges, but you can't do, you can't set an actual value in there without doing, hundreds of commands. That sample file actually has a volume up and volume down buttons on the top of the gauge. So you press the top of it, it goes up, press the bottom, it goes down. The gauge itself, on its bar graph, uses that integer variable we talked about before. But it uses it multiplied by 10 once again. So if you go up to the graph tab, you'll see that the range there, rather than being from the Yamaha itself, its volume range is from minus 80 and a half to 16 and a half. Because we use that 10, we have to go from minus 805 to 165. That way we can do that without losing the resolution. You can do it without that, but you'll only be moving half steps. You can hit up. It might not move because it went from 60 to or minus 60 to minus 55 point 60 minus 59.5, and I guess that would change. But then when it went to 59, it wouldn't change, right, because it would be rounding. So you'd only see change half the time. So this lets you actually keep the full resolution. Every change in the volume can be reflected on the gauge. So if we close this, we can show, we have above it the actual text value, and you can see again that we're using that string variable, the integer variable. But this is how you get that variable back into the decimal form. So now we've got to actually divide it by 10 again, and then we're going to show it with 1 decimal point. So that actually, that becomes essentially invisible to the people who are looking at it. You get the full resolution on the graph, but they still see the numbers correctly, same way they do in the front panel, which is kind of what you want. Otherwise, you would end up seeing, well, the one above it, actually, but you would end up seeing that minus 805 to 165. Minus 805. 805 is really, really soft. And that's I mean, that's pretty much what it does. Once again, you You can send whatever string you want. When strings come back in, you've got to know exactly what the string is so that you come up with a match for it, and that'll let specific events happen when strings come in. But it also, if you know inside that string, there's data that you want to turn into a variable, it lets you frame, put frame around that data, a prefix and a suffix on that data, so that the driver can take what's in the middle out and create a string. If it can do that, it can create a string. If that happens to be a number, it can create an integer out of that. It can scale it. So you can pretty much get. I mean, there's just a huge number of devices that this works with. So that's a lot of data. If this page right here, like I said, it gives you input switching. You can see the status of the input. You can turn on power. You can see whether it's on or off. You can see metadata from the streaming devices. You can see what volume it's on. All of that without a driver.
Well, should we show them?
Yeah. Do we have that?
Let me show them what it looks like here real quick. So here we have it. Virtual panel running here. All right. Well, we should see what's going on here. TCP 158. Make sure that's the right address here. Interesting. We got this yesterday, so I wonder why it's. It's called what again?
I think it's a 2000. That's actually RX
2000. Where is it?
Blame the tech support guys.
Oh, let's see. Yesterday. All right. Well.
We're trying to be overly smart here. There's a Yamaha in my office that we connected to yesterday, but
Wonder where it went. Well, that's interesting.
this would have been really awesome.
Where did it go? I don't know. Interesting. Well, the tech support guys must have taken it. Let's blame them. But essentially, yeah. I mean, what you're going to do is you're going to get all the information here, and oh, there it is.
That's once again, that's a sentiment. Every button you press will change to show what you sent.
For some reason, your receiver's not in there. Will this driver be able to show track duration when using it with a CD changer?
If the CD changer sends out a string that has track duration in it, then yes, it will. You have to find out in the documentation what that actual command string is that gets returned. It will have to have sent it, but yeah, if that data is in a string, and that string, you have data, a way to frame that data, then certainly, yeah, you'll see it in the string. That's data is usually harder. Um, you know, probably won't be able to turn that into, like a graph of duration, but uh, like a elapsed time thing, but certainly duration, I would think you could do. I mean, once again, this driver is intended to work with any device. So it all depends on the device. The mechanism is in there to match up strings, to strip the front and back off strings, to turn them into integers. It's all up to the device. It's not going to work with every single device. If it did, boy, driver writing would be much easier. But but it's going to do a large number of them. It'll be a definitely with things like receivers and projectors. We were talking about that yesterday about it's great for projectors. Projectors you usually don't need a whole lot of information from, but there's so many of them with so many different protocols that this is a great way to do a lot of that.
Could RTI just build a serial driver for the Integra CDC-3.4 then?
No. No, but holy cow, you can use the two-way strings driver and you can do it yourself.
Hey! And then show it off to us.
Yes. There are always, this is the point. If I could write 8 drivers a day, we would still have people complaining that we aren't doing enough. I mean, there are always going to be, I can only write 7 a day. There are always going to be devices that there aren't drivers for.
Well, again, it doesn't come down to you writing them. It comes down to the other 2 parameters. Is there a need, and do we have the equipment?
Right.
And
exactly. I mean, that's and to be honest, but even with those parameters, even with manufacturers who are trying to get us to do their stuff, us trying to find drivers that fill in different niches that we haven't been in before, trying to broaden in certain areas.
Like the irrigation caddy.
The irrigation caddy was a great example because we didn't have any irrigation drivers, so we wanted to make sure we did that one. There are the list of drivers is we have our driver writing meeting. The list of drivers to write is depressingly long, and stuff like that. And in particular, like a CD player, there's just not enough. It's not important enough really that you get that data back to.
Well, it's not.
It's not important.
It's not to say that the equipment they're using is unimportant. It's just there's other things.
That's him being politically correct.
Well, there's other things that take precedence based on overall demand.
Yes.
I mean, again, it's not that we don't want to provide everything, but this is a way that you can help yourself until maybe that does occur, and that's what the two-way strings driver is all about. Another question that came in that I thought actually came in when we first started, but I wanted to hold off until we started opening up a few more questions. Integrators.
This isn't about the Christmas party again.
I'm finding more instances where I have multiple units, i.e. 3 LG TVs, so I have to load 3 occurrences of the driver. Is this a major impact, and will newer drivers have the ability to talk to / control multiple devices? I think that's a great question.
Yeah, more and more in drivers, you're seeing a selected player. You see that in most of the media ones, a selected tuner. In TVs, I don't know that. Well, we don't have that many TV drivers actually, but in TVs, I don't know that we have that many of them. I think there's been some reluctance to do that in the first place. That is actually one of the pushes of Apex is to make switching devices and drivers and duplicating things and pointing them at other things. That's the major push of that. There's a lot of drivers that do a lot of stuff. There's a lot of stuff we put in drivers. There's a lot of third-party drivers that do stuff that really um, has no business being in a driver. When you look at the specific, just you know, dividing up the tasks of what goes on, what a driver should do, what ID should do, what the device should do. The drivers have tried to fill in a few holes. That's what the selected thing does. It is our hope that eventually all that selected stuff actually comes out of the driver. It really isn't, when we're switching all that stuff around and switch between multiple devices and multiple ports, that's not really defining for the processor the protocol or the commands that does. They're not really commands of the device. It's not really part of the device. That's really something that the processor and ID should do between them. Um, a lot of that came up, when we first started doing RTI panel stuff, where suddenly all of our remotes are multi-room remotes instead of just in one. And once again, that's the bottom line. There is that's ID's job. Apex is going to work on making that easier, and so we're hoping to do less of it rather than more.
Another question that came in: could you add version number to the zip file naming convention in your download site? Let's see why not.
Well, that's not really on the point.
No, but it's a good idea. So we'll take it to the house. If we have more than one device to control, can I load more than one instance of the driver? Yeah.
Yep.
Because it's basically just you could load many of these versions.
You can load as many as you want. You can load as many. Well, I shouldn't say as many as you want. You can load multiple instances of any driver. There are no drivers that you can't load multiple instances of. Right. Drivers do not get in each other's way. So yes, you can always load another instance of a driver.
Sure. Absolutely. Great questions, everybody. Appreciate it. All right. Well, it does look like one of our tech support guys took and borrowed the Yamaha receiver. So, unfortunately, what we were going to demonstrate, we can't. So, I wish we had known that they were going to take it. We would have put something else in there or said don't take it. But you can see at least that it is occurring. The commands are working because down here we are getting the return string or the transmission string. Yeah. So, and you're seeing how that's all laid out for you here as well. So, in the number of times that I've put on different ones. Anything that they should be careful of, anything that they should, be cautious of when setting this up and using these and making sure that they have good understanding on?
Well, I think, once again, it's this is as detailed kind of work as you can get. It's just so easy in a lot of these to to get these strings wrong. I mean, most of you have done work with strings out of a button with a serial string driver, or had to make those string libraries yourself. And the same thing goes with this. You have to make sure that you have the documentation so that you get that right. Make sure that there is a connection, and that you see the connection turn true before you worry about your commands. And look at the actual RX string you get compared to what you have in the configuration. I mean, it's all going to be detailed, and the driver and the device don't care if you're close.
Right.
So it's when you start doing this on a device that doesn't have that you're trying to control, it's going to take some time to do it. It's kind of a tedious sort of trial and error sort of thing. So.
Very cool. Anything else we should cover real quick? You can think of? Okay. Might there be a question that just came in, might there be a way like changing IR routing to change driver routing for when you have multiple instances of the same driver? I'm not sure I understand that because you're going to individually address them.
Yeah, not in this driver. I mean, once again, you're asking a whole global question that we had another hour, maybe we could have that discussion, but actually, Tyler and I are the wrong people to have it with. Uh, so once again, this goes back to, making it easier to switch, just like I had said before, between different instances of drivers, different devices, or making a single driver control multiple devices. Once again, that's all, stuff we're working
Right.
on. And so if you're asking if that possible, yes.
Yeah, and it will be. One of the major things about Integration Designer Apex is room-based programming, so that you'll be able to put a driver in and then determine what, and say, okay, it's in this room, and then have it go correctly to those locations or multiple devices or what have you. So, very good. All right. So let's just finish up here with, oops, wrong button. Second here. There we are. Come on. Oh my gosh, so many issues today with this thing. All right, screw it up. But, oh, honestly. Back to square one. All right.
A quick review.
Sorry about this, folks. PowerPoint decided to quit on me. Talked about that. Two-way strings. All right. So basic key. Oh, now it's gone too far. So basic key takeaways for you here is that you're actually going to provide greater customer satisfaction in the end, because what you're offering them is now the ability to have feedback on that specific device that maybe nobody else does or can because they don't have a driver. This driver will give you that ability to get that information to them and provide it so that they know what's on, what's not, what's the source, what's the signal, what's the pardon me, the name of the artist, all that kind of fun stuff. Also, read the get info and get those protocol docs. You can't do this without those protocol documentation. You can't do it without reading that get info and having an idea on how it's set up. You've got to do these things, folks. Otherwise, you're gonna make more work for yourself than anything, and then we don't want to see that. We want to lower the overhead costs and lower the programming time for you, and that's why we provide these things for you. So make sure you get those, get the protocol docs, and you'll be good to go. A couple other questions here, real quick, that came in. When you configure the driver in project and it's operational, can you export the driver with all the configuration and import other project files and have all the config transfer?
Uh, yeah, like we were saying before, all those strings. There's uh, a button in the driver tab on your uh, processor page for exporting the configuration. So all of your strings, all of your prefixes, all of your suffixes, your multipliers, your framing, your port connections. I mean, obviously, the next time you import it, it'll probably be at a different IP address. Um, but um, all that stuff gets exported, and when you load it in again and import it, those will all fill back in. What doesn't get imported and exported is the commands, because every button has its own string. So in that case, you might, like we were talking before, you might want to create a page that's got all the commands you need on it, even if you're just kind of, it might not be the exact page you're going to end up with, but it's going to have all the commands on so that you can import it and then put it the way you want on the system you're working on.
Perfect. All right. So basically, folks, some additional resources for you: the forums, technical bulletin, update, mailing list. Make sure that you have any additional questions. You shoot them over to us. We're happy to answer them, as always. And just a little heads up for you. Very, very soon, like very soon.
It's actually very soon. We just got word today that HEOS is waiting for Apple approval on the new version of um, their app, so that they can release the new firmware that actually allows external control. And I think what you'll see with HEOS, just like we saw with Nest, you'll see that the RTI driver is the first, if not, one of the first, if not the absolute first to be released of any major control company.
Perfect. So we'll go ahead and open up to questions for another 10 minutes or so here. But if you, go ahead and stop the recording. But thank you, everybody, for your time. We do appreciate it. We know it's a significant investment on your part. So we do thank you. Please keep in touch. Let us know how we can help. And have a great day, everybody. I'll go ahead and stop the recording, but leave the line open for any questions.